So let's look at the last part of this lesson. It's been quite the lesson. So yesterday we had things in parentheses that created this horizontal translation, which is a phase shift, right or left. So today we're going to finish this last horizontal translation or phase shift. And this one is different because the two that we did yesterday were the same, pretty much the same key points that we've had in the past, only we just moved them to the left a little bit. This one's not going to be quite the same. It's going to be harder to partition out your x-axis. We're going to talk about what happens when we have funky fractions and how do we deal with that on our x-axis. So look at what happens with this one. What's our amplitude? 1/2. So here's our amplitude, 1/2. Our period, what is the coefficient in front of x? 1. So that means that's what b is. So I'm going to take 2 pi and divide it by b, 1, which means that my period has not changed. It's still 2 pi. So because of that, I'm going to take that 2 pi down here and divide it by 4 to get my increments. And doesn't that reduce to pi over 2? Which, as you'll see, is going to cause an issue. Now, look at what's in parentheses. Logically, we can determine what direction this is moving and how much. Because the coefficient in front of x is 1, it's not so difficult to figure out. Is my movement right or left? Right, and how far? Pi over 3. Okay, so we expect our starting point to be at pi over 3. So let's find our start and our end. So we have our start and our end. What is in parentheses is x minus pi over 3 equals x minus pi over 3. So always take what's in parentheses and set it equal to the normal start of a period for cosine or sine and the normal end of that period. So what's our normal start to the sine curve? 0. What's our normal end for that period? 2 pi. So the start's not so bad. We're going to add pi over 3 to both sides. So we get x is equal to pi over 3. So that's my start. That also means that we learned yesterday that's our change in our vertical axis. So that x equals pi over 3 is going to be our change in our vertical axis. Bless you. Don't go and mark that in here real quickly yet. You're going to see it's going to create an issue. So let's find our end. Our end's a little bit more difficult to find. If I add pi over 3 to both sides, add 2 pi and pi over 3 are not the same. So you should be putting the 2 pi over 1. What's the least common denominator between 1 and 3? Least common is what? 3. So I would be multiplying this by 3 and this by 3, and that one stays the same. So my actual end is going to be at x equals, this is 6 pi plus a pi. So isn't that 7 pi over 3? Are you okay with that? 6 pi, 2 pi times 3, 6 pi plus 1 pi gives you 7 pi over 3. What is the difference between 7 pi over 3 and 1 pi over 3? Subtract those, what do you get? 6 pi over 3, which reduces to? 3 pi over 6 pi over 3 reduces to 2 pi. Isn't that what my period is? Right? And so the difference between your start and end should be your period, which it is. Do I have any addition outside or subtraction outside of parentheses? No. So there's no up-down movement. So our horizontal stays at y equals 0. Bless you. So all that's left is to find our key points. So to find my key points, I'm going to take my start, which is, so here's my key points. I want to take my pi over 3, and I want to add to it pi over 2. Do you see why this is an issue? I can't add those the way they are. What's the least common denominator? 6. So this one gets multiplied by 2 over 2, and this one gets multiplied by 3 over 3. So I end up with, I've got 2 pi here and 3 pi here. Doesn't that give me 5 pi? 2 pi, 3 pi gives me 5 pi over what? 6. That's our second key point. If I were you, because that's over 6, instead of adding pi over 2, I would add what we just converted it to. I would add 3 pi over 6. Makes life easier. And I'm not going to require you to reduce your key points. You can leave them unreduced. It's easier, and it's really not important that they're reduced. So we've got 5 pi plus 3 pi is 8 pi over 6. You'll see why I'm allowing you to have them unreduced in a minute. So that's 3. I need 2 more. I'm going to add another 3 pi over 6, and that's my pi over 2. And I get 11 pi over 6. So there's 4, and 1 more. 3 pi over 6 gives me 14 pi over 6. 14 pi over 6 reduces to what? 7 pi over 3. And so that's the end of those. Alright, so they're all over 6 with the exception of this one. This one we can view as 2 over 6, 2 pi over 6, right? So whatever your denominator is, that's what we need to partition this at. Because, don't do what I do. But if I went up here and I did what we've been doing all along, and I went every other one, okay? And I started here at pi over 3, don't do this. And then I put 5 pi over 6, and then I put 8 pi over 6, and then 11 pi over 6, and then 14 pi over 6. Okay, you're like, well, what's wrong with that? What is the distance between here and here? How far apart is it from 0 to pi over 3? Pi over 3. What is the distance between those two? What's 5 pi over 6, and then remember this is 3 pi over 6? What's 5 pi over 6 minus 3 pi over 6? Oh, I'm sorry, I totally wrote that wrong. Multiply that by 2. Isn't that 2 pi over 6 and 5 pi over 6? What's the difference between those two? 3 pi over 6, which is pi over 2. Are those the same distances?
No.
Remember we were adding pi over 2 each time? Can you have your increments different distances apart? No. Remember, 0 is no longer one of our key points, so it poses a problem. Instead, how do we partition our graph? What is the denominator of each of the key points, with the exception of one of them? 6. So if I were you, whatever your least common denominator is, in this case 6, I would partition my graph out into 6. So whatever your LCD is, partition it out into 6. So if this is 0, here's 1, 2, 3, 4, 5. This is 6, 6. Won't that be pi? Right? And then 1, 2, 3, 4, 5, 6. This is 2 pi. 1, 2, 3, 4, 5, 6. There's 3 pi. And then to the left, 1, 2, 3, 4, 5, 6. This is negative pi. So here's what I would do. We have a new starting point, and our new starting point is pi over 3. So that pi over 3 is no different than, remember we converted it here to 2 pi over 6. So I have to find 2 pi over 6. This is 1 pi over 6. Right here is 2 pi over 6. So I'm going to start here, moving my vertical axis to my starting point. X equals 2 pi over 6, which is our pi over 3. Then I'm going to mark every single one of my key points on here. So this one right here is 2 pi over 6. That's the first one. And the second one, if this is 2, I need to get to 5. So 2 3, 4, here's 5 pi over 6. I need to get to 8, so 6, 7, this is 8 pi over 6. I need to get to 11, so this is 8, 9, 10, here's 11 pi over 6, and finally I need to get to 14. So 12, 13, here's 14 pi over 6. You're like, oh, that's a lot of stuff in there. Take a highlighter. I want you to highlight those key points and you'll start to see the pattern between them. So here's my first highlight right there, right there, right there, there, and there. How many grid lines are apart from them? How many grid lines? 3. So if I were you, I would then go, when we're done here, and highlight every third one, but wait a minute. Because remember, we like to draw in one full period first, and if you put all those in there, then you're going to forget what your full period is. So let's go ahead and draw in one full period. We have all the information that we need to do so. It is sine. Does sine start up at the amplitude or down at 0? Down at 0. We need to also partition out a vertical axis. So our amplitude is 1/2. You can do what you want. I'm going to put this as 1 so that that's a half. And this is at -1. So this is my new start line. Sine starts at 0. So here's 0. Then my next increment I've highlighted. My next increment I'm going to go up to my amplitude, which is right here at 1/2. And then the next one that I've highlighted is at 0. The next one that I've highlighted is down to my amplitude of -1/2 and back up to 0. Then draw that in. Does that look like a normal sine curve? So now for once it does look different because for once we're being forced to partition the graph more accurately, right? And then from there I can finish out my pattern. So if I were you, and I know it helps me, I would be highlighting every third grid line to help me with where my pattern points go. Or you can use a red pen. Bless you. Red pen, highlighter, they both do the same thing. So then I'm going to finish out that pattern. So I went down and then 0. So now I'm going to go up. So I didn't get very far on that one. And then here, remember 0 is no longer a key point. So at this one, I went at 0, so I'm going to go down, back to 0, and then up. So the highlighter really focuses your eyes on where your change goes, where your pattern points go. You okay with that? Questions on that? Issues? Problems? Concerns? You feel comfortable with that? The hard part is partitioning out that x-axis. All right, so let's look at this one down below. This one's a bit of a doozy. It's a little hairy. It's got a lot going on. It's got 4 things going on. What's the first thing you notice that you haven't had before? It's a negative. You have a negative. Remember what we talked about that negative means? Well, the amplitude is positive, but what does the negative mean? It's a reflection. So that negative, you might want to draw an arrow here, that negative is a reflection over, it's happening outside the function, it's happening on A. So remember what we said when A is negative? It reflects over the x-axis. Why? Because it's affecting Y, so it always reflects over the other axis. So we're going to do that reflection last. So you might want to put on here that we're doing it last. It's easy to forget about the reflection. So it's really important that you write yourself notes as you're doing this. Don't forget to reflect, or reflect last, or something like that, because you're going to forget. What's our amplitude? So this is our amplitude right here. So amplitude is 3. If you have a change in amplitude, we have a reflection. There's 2 out of the 4. Don't you see something in front of the x? 2 pi, what is that? A, B, C, or D? B. So we're going to take, and that affects our period. So we're going to take our 2 pi, which is our normal period, and we're going to divide it by 2 pi. What does that mean our period is? 1. Which is nice because 1's much easier for you to partition. So I'm going to take that period of 1 down here, and we're always going to divide it by 4. It doesn't reduce, so our increments of our period go by fourths. But I have to figure out the starts. Since I have parentheses with a plus in it, that must imply I have a horizontal translation. Is it going to be right or left? Left. It may not be left pi over 4 because we also have a period change. So that's why it's really important to use a start and end. Now your textbook is going to take this problem and it's going to try to factor out the 2 pi, which isn't so bad because this one you can factor 2 pi out of. But imagine if this were like 5. How hard is it to factor out a 2 pi from 5? It's hard. So that's why if I were you, I'd use my method and not theirs. I find it easier. So we're going to do our start and our end. So the math on this is a little bit more cumbersome. But we're going to take exactly what's in the parentheses. 2 pi x plus 4 pi. And set it equal to something. And then 2 pi x plus 4 pi. And set it equal to something. What are we going to set the start equal to? 0. 0 is your normal start for a period of cosine. What's your normal ending for a period of cosine? 2 pi. So we're going to solve for x. So the first thing we do to get x by itself is to subtract 4 pi. So I get 2 pi x equals negative 4 pi. Then to solve for x, divide by 2 pi. What does x equal? The pi's cancel and you do indeed get negative 2, which makes sense that the pi would drop out because our period is 1. So you shouldn't get a pi in this answer. There are ways that you could, but I'm not going to give you any ones that it wouldn't. And so solve here, subtract 4 pi. So 2 pi x is equal to 2 pi minus 4 pi. Isn't that negative 2 pi? Divide by 2 pi. What does x equal? Negative 1. That's our ending key point. What is the distance between negative 2 and negative 1? 1 isn't that our period. So it matches. Didn't we just find our vertical? Our vertical, remember, comes from the start answer. So our answer to our start is x equals negative 2. So that means I know I'm starting at x equals negative 2. Are there any addition or subtraction signs outside of the function? No. So my horizontal has not changed. It is still y equals 0. All that's left is to find my key points. So here we go. Key points. We're going to start with negative 2. And we're going to add our increments of 1/4. For those of you who have a little trouble with fractions, put that 2 over 1. What's the LCD between 1 and 4? 4. So I'm going to multiply this by 4 and this by 4. So don't I get a negative 8 here plus a positive 4? I'm sorry, negative 8 plus 1. Doesn't that give me a negative 7/4? Then if I were you, I would keep adding 1/4. Again, remember I told you you don't have to reduce. So then I get negative 6/4. That gives me 3 of them. So add a 4. I get negative 5/4. And finally add a 4. And I get negative 4/4, which is negative 1. Isn't that my start and end point? Which is what I'm looking for. So it's another check. Alright, so I have to change my starting point and I have to partition out my x and y axis. So let's start out with partitioning my axis and then I'll put in my new start point. So our amplitude is 3. So it makes sense to leave these going by 1. So I'm going to mark that as 3 and that is negative 3. What do I want to partition my x-axis into if my denominators are all 4 or LCD is 4? 4. So we're going to count from 0. 1, 2, 3, 4, here's 1. And so there's no pi because pi disappeared. And then go to the left. So I need to mark in my key points. Well, my key point starts at -2. That's going to become a little bit of an issue. -2 is out here, isn't it? I'm missing a grid line, and that is my starting point. But it's only off the grid by 1, so I can easily add that in. And so I'm going to put in my dotted line, because that's my new start line, right here. And that's at x equals -2. So if -2 is my starting key point, I'm going to highlight that, -2. And it goes in every fourth from there. Isn't this marked in the fourths? So -7/4, well this is -8/4. -7/4 will be here, -6, -5, -4/4. That is going to be one period right there. So we have a lot of waves to put in this one. But I would start right there. And we are plotting cosine, because cosines start up at the amplitude or down at 0. Up at the amplitude. Plus, don't forget, we almost forgot, we have a reflection. So I'm going to start off with using a green pen, because we're going to do a dashed line. Because what I'm going to plot now is not the actual graph. I'm going to plot the normal cosine without a reflection. So normally our cosine at -2, so our new starting point would be up at 3. So this would be our normal start point, up, and then our next increment would be at 0. Our next increment would be down to our amplitude of -3, back to 0, and then up again to your amplitude. So that would be without a reflection. If we're reflecting over the x-axis, we have to look at the distance that each of those points are from the x-axis. Isn't this point 3 units from the x-axis? So I want to go 3 units on the other side. So this point ends up at -3. Any point on the x-axis, they're on the line of reflection, they stay there. So I keep that 0 point. This point goes the opposite direction, so it goes up to +3. This stays at 0. And this point here goes down to -3. So really what I have is this. It actually looks like a bell curve for once. That's the pattern I'm going to be starting. And instead of highlighting every single grid line, isn't our pattern every single grid line? And so if I were you, I would plot my points for one period at a time and draw in your curve. Because there's so many curves to draw in here, you're going to get lost in your points. So I started down, bless you, and it's going to go 0 up, 0 down, 0 up, 0 down. And so we're going to go 0 up, 0 down. And I'm going to just draw as I go. 0 up, 0 down. And what you'll start to notice is that at every whole unit point, you're down at that end. So reflection wasn't that bad. I like your sweater. All right, are there questions on that one? All right, so let's finish these out. Flip it. This time, let's look at what happens with the vertical translation. Finally, we get to something that looks so much simpler. It's been a long time since we had simple. Notice the only thing that's different from the general graph of sine is we have a -4. There's no parentheses. So whenever there's no parentheses and it's outside the function, it's a vertical translation either up or down. So it's up or down translation. So is this one going to be up or down?
Down.
Down. So remember, it's the same sign outside the function. So this is down 4. And immediately I know my horizontal axis has moved. If it's moved down 4, what axis is it going through? The y-axis. So it's y equals -4. I immediately am going to draw that in there. So I'm going to go by ones. And I'm going to draw it in with a dashed line because technically it's not part of the graph. We haven't really moved the x-axis. We just sort of moved it. Remember, that 0 line is where our amplitude is the same distance above and below the line. So we're going to plot our amplitude based upon this line, not this line. And so I'm going to mark this as being -2, and this as +2, and +4. So what's our amplitude? 1, because the number in front of sign is 1. Bless you. Now, we can start to eliminate some of our work. Is there a period change on this one? Is there a coefficient in front of x? No, so there's no period change. What should be the normal period? 2 pi. We've done enough of these by this point that you should realize that. So since there's nothing in parentheses being added or subtracted, has our vertical axis changed? No. So that goes through the x-axis, so it's x equals 0. And what is our period increments going to end up being? We've done this a million times. 2 pi, pi over 2. And then since it's pi over 2, and our period is 2 pi, and our vertical hasn't changed, what's our starting point? 0. And don't we already know the key points? Aren't they the points around the unit circle? Do we have to calculate them at this point? No, right? So think about what's around the unit circle. 0, pi over 2, pi, 3 pi over 2, 2 pi. So let's partition it out. So since we're using those, we can go back to our old method of going every other. And I'm going to label my one period of key points. And we're ready to start graphing. Sign, does it start up at the amplitude or down at 0? Down at 0. So normally 0 would be here, but our 0 line is moved down here. So we have to start our sign all the way down here. Then the next increment is here, and sign goes up, but it only goes up to the amplitude. Well, the amplitude is 1, so we only want to go 1 away from the 0 line. Question?
Is that a good question? When we first started doing, we used to exponents for
No, because that's not in parentheses. Only if it's in parentheses would you do that. And so because it's not, I don't have to have a starting line. So it's a good question. So we go 0 up, and then our next increment is back down to the 0 line. Our next increment is below the 0 line, 1 amplitude unit. And our final increment is at 0.
Why aren't you going up more? Like, why are you
Because our 0 line, because of the -4, our 0 line is moved from here now down to here. So instead of working off of the x-axis, we have to work off of that new 0 line. And so my amplitude is still 1. From here to here, that still has a distance of 1, and from here to here is still a distance of 1. So if my amplitude had been 2, I would be going up to here.
Okay.
Does that make sense? So it's kind of changing your viewpoint down to that new 0 line. And then from there, can I finish off I want to finish my partitioning. So again, every 4 grid lines is pi for every 2 increments. So this is 3 pi, 4 pi. And then this would be negative pi. So if you want to finish off marking those. And then mark in your pattern. So up, 0, down, 0, up. Down, 0, up. You okay with that? Just a little uncomfortable using a new 0 line. Okay, let's do the last one and then we'll talk about writing the equation of lines. So this last one, tell me what's going on here.
There's addition.
There is addition. So does that mean vertical or a horizontal movement?
It's not in parentheses.
It's not in parentheses. So there's no start and end. Remember, in parentheses implies a right-left movement. So outside of parentheses implies a what? Up, down. So is this up or down? So it's going to be up 2. So immediately I move my horizontal line up 2, which would be right here. Because if you don't move it immediately, you forget. And notice that the up 2 is in front of the function, which is fine. It can be in front of the function. What axis is this line going through? What axis? Y-axis. So it's y equals 2. So that's my new horizontal, y equals 2. What's my amplitude? It is 3. What's B? 2. So my periods change. So I have a period change, I have an amplitude change, and I have a vertical change. So I have 3 things going on. So 2 pi divided by this 2 gives me what? Pi. So let's talk about vertical and horizontal shrinks. We have a vertical going on. Do we have a vertical stretch or shrink going on? Yes. Is it a stretch or a shrink? It is a stretch of what factor? Nope. The movement, this movement up 2 is not a stretch. What is the stretch? 3. The amplitude is your stretch. So this is a vertical stretch of a factor of 3. Because it's stretching that up higher. Horizontally, we have a period change, right? So our period change went from normal period of 2 pi down to period of pi. So that's a horizontal shrink by a factor of pi. So here we go. Let's find so did our vertical change at all? Are there any parentheses with plus minus? Nope. So our vertical goes through the x-axis, so it's x equals 0. But we have to find our key points. So take that new period of pi, always divided by 4. It doesn't reduce, so our increments are going to go in pi over 4. We don't have plus minus in parentheses, so we don't need to do a start and end because our normal start is 0. So 0 plus pi over 4 gives us what? Pi over 4. Pi over 4 plus pi over 4 gives us what? It does. So I'm going to write it as 2 pi over 4 to help us out here. Remember, you can write it unreduced. It is pi over 2. And then 2 pi over 4 plus pi over 4 is what? 3 pi over 4. And then finally add another pi over 4. And what's 3 pi plus pi? 4 pi over 4, which is just pi. So that I am going to write out as just pi. So, what's my LCD? 4. So I want to partition my horizontal axis into 4ths. So every 1, 2, 3, 4, that's a pi. 1, 2, 3, 4, 2 pi. And go left. this graph, this is 2, so this is 4, this is -2. So if I were you, I would mark every one of your key points. So this is pi over 4, 2 pi over 4, or you can write it as pi over 2, 3 pi over 4, and 0. So there's your 5 key points. So again, we're going every single grid line. We are plotting cosine. Does cosine start up at the amplitude or down at 0? Up at the amplitude. Now we don't have any reflection, so here's my normal 0 line. Well, here's my new 0 line. And we're going to go up to an amplitude of 3. So we have to count up 1, 2, 3 units above the new 0 line. So there's our actual starting point for cosine. Then our next increment goes down to 0. And then our next increment goes below. So we have to go below the distance of the amplitude, which is 1, 2, 3. So we're really at -1. Back to 0. Back up a distance of 3. And then draw that in. Isn't that your normal cosine curve? Then you need to do every increment following that pattern. So back to 0, down 3, back to 0, up 3. So again, because we're going every increment, I would draw as I go. And you'll find this time that at every whole pi, you're up. You want to look for those patterns so that if you make a mistake, you can catch it. Very easy to make a mistake. So how do we feel about that one? It's not so bad, right? You okay with it? I actually find this last part easier than graphing. You have to look at the graph that they've given you and determine what's the equation. Now the important part is that you need to know that general equation of sine or cosine. You basically have to find the amplitude, period, and phase shift, which is our right-left translation for the function, and also our up-down translation. You have to determine, is there a right-left movement, up-down movement, is there a period change, what's the amplitude, and that'll help you find A, B, C, and D. I'm not going to do something complicated to you where there's both of those. So you're either going to have a B or a C, but you're not going to have both. So that'll make it easier. So let's look at this one right here. Start off with determining what the period is. Is there a period change? Well, let's figure out what the beginning and ending points are. If this is pi and this is 0, what's this point here? Pi over 2, right? So this is 1 pi over 2, 2 pi over 2. What's this one? 3 pi over 2, 4 pi over 2. So what's this one? 5 pi over 2. So if I took 5 pi over 2 and I subtracted pi over 2, so let's find our period, 5 pi over 2, and I subtracted pi over 2. What do I get? 4 pi over 2, which equals 2 pi. Is that our normal period? What determines our normal period? A, B, or C, or D? B. Now, if that was different than 2 pi, all you have to do is take the 2 pi over B and the 2 pi and put it over, or whatever this is, put it over 1 if it's not a fraction. Couldn't you set up a proportion and cross multiply and solve for B? Right? So if that isn't 2 pi, then you can find B easily by setting up a proportion. So we know then that B is equal to what? 1. So I know B is 1. Then look at your distance above your 0 line and below your 0 line. There's no markings here, so I can only assume they're going by 1. So this is a distance of 2, and this has a distance of negative 2. So what does this distance tell me? My amplitude. So what's my amplitude? 2. And that means that A is equal to 2. Uh-huh. Because I needed to find my period to see if B had changed. And so to find my period, I have to take the bigger number and subtract the smaller. The endpoints. Yep. And mostly because hasn't there been a phase shift here? There's a definite phase shift, right? The graph has moved to x equals pi over 2. Is that pi over 2 going to be A, B, C, or D? Well, but we know our period has stayed the same. And so that means that B is staying at 1, so we know we have x. So my question, I guess, is this pi over 2 going to be C or is it going to be D? It's a right-left movement, isn't it? We're not going to do inverses right now. Don't get complicated. Is this a sine curve or a cosine curve? You're just doing sine or cosine. You're not going to do like cosecant or secant today. This is a cosine curve. Okay, but this is not, so I don't want to complicate it with something that's not right now. Are you talking about reflection? Okay. If it's a reflection, then yeah, it would be, but it's not. So if this were reflected, I would expect to see this down, right, and that one up. So you could tell if there's a reflection by looking at, does it not look normal and why? Okay, so the reflection of the cosine, remember we did. So here's your cosine. If that were reflected, this would be up, and that would be down. Okay, you and I will talk later, because you're complicating issues for other people that we're going to. So you and I will talk later, and I'll draw something. Okay, so I moved normally from here. Did I move this to the right pi over 2? True or false? True. Right movements, do they occur inside the function or outside? Inside the function. So won't it be in here at C? But because it's right, is that a plus movement or a minus movement? It's a minus. So that implies that C is equal to negative pi over 2, right? So my vertical, even though it's x equals pi over 2, the C is negative pi over 2. Has my horizontal changed? Is that the same distance here as it is here? Yep, so my horizontal hasn't changed, it's still y equals 0. And I don't really care about my key point increments, that doesn't matter for my my equation. And so if my horizontal hasn't changed, isn't D equal to 0 then? Because there's no up or down movement. So we're ready to write our equation. So my equation is y equals, it's an equation, so it has to have an equal sign. My altitude is 2, so A is 2. What did we say this was, sine or cosine? Sine. We want to recognize what kind of curve that is, so that's why it's sine. And then I do have a right-left movement, so I need parentheses. My B was 1, so I just have an x. But my C was minus pi over 2. And since D is 0, I don't write plus or minus 0. So that's it. If I didn't have a right or left movement, I wouldn't have parentheses. There's questions on that. All right, let's do our last one. So our last one, is this sine or cosine? So it's cosine. Is there a reflection going on here? No. So this is cosine. No reflection, and there was no reflection on this one. Now, I will tell you right now, I'm not going to do a reflection over the y-axis. because it's harder to see, because a reflection over the y-axis would look like to you like a left translation, wouldn't it, on here? Wouldn't it? So I'm not going to do that to you, but what I could do is a reflection over the x-axis. So be prepared for that. All right. All right, so it hasn't moved right or left, has it? No. So our vertical is still, it goes through the x-axis. So our vertical is x equals 0. So if that's the case, then that means that c is 0. There's no parentheses. Let's look at our period. Our period goes from 0 to 2 pi. What's our period? No, what's our period? 2 pi. Yep, so our period is 2 pi. That hasn't changed. What does that tell you about b?
0.
b is equal to not 0, but 1. So far I have the cosine of x, no parentheses. Has this been moved up or down? Yeah, it actually has, because it's not even touching the x-axis. So what you want to do is find your highest point, which is here, and your lowest point, which is here. What's the distance between the highest and the lowest point? 2. Half of that is 1. So I want to draw a 0 line directly cutting that in half horizontally, because your 0 line should be cutting your graph in half horizontally. What axis is that new 0 line going through? Well, what axis though? Y. So it's y equals 2. So that means our horizontal is now y equals 2. So what does that tell me about A, B, C, or D? D is positive 2. So it's outside the function is vertical, and it's the same sign. So D is positive 2. All that's left is my amplitude. Now that I have my new 0 line, isn't this the distance my graph is above, below the 0 line, and my distance above? How far is that? 1. So then my amplitude is equal to 1, and that means that A is equal to 1. So now I'm ready to write my equation. Y equals, my A is 1, so don't write anything in front. It's cosine. I don't have a right-left movement, so I don't need parentheses. My B is 1, so I just need x. And then I do have an up movement of 2, so I just put a plus 2 on the outside. And that's it.